Hello, ladies and gentlemen. Welcome to yet another exciting lesson from SAGT Tech. My name is Asaf, and I hope you enjoy this one. Today, we're going to be talking about pneumatics and hydraulics, grade 9, term 2, lesson 1, as compiled by myself, K. Pelwane, for SAGT Tech. Starting from the beginning, we're going to look into the policy as per our CAPS document, which says that we only have pneumatics and hydraulics in grade 7, and in grade 9 we do not have such in grade 8. And in grade 7 they only do the pneumatics and hydraulics used to increase human strength, and you'd recall that they also have a pet that's using pneumatics and hydraulics. And in grade 9 what is done is the interacting mechanical systems and subsystems, hydraulic principles, incompressibility of liquids, pressure in liquids, force transfer, hydraulic and pneumatic systems that uses restrictors, one-way valve, hydraulic press, jacks, and so forth. And we also are going to be looking into different pads as done in both grade 7 and grade 9 in hydraulics and pneumatics. Now, the pads. In grade 7, they're doing hydraulic powered rescue machine. You would recall that they're making a model of Jaws of Life. Just the basic to hydraulics and pneumatics. And you get to grade 9, the pad is solving a problem that can be solved by using mechanical systems integrated with either electrical or electronic, hydraulics, or pneumatic systems. I always advise teachers and learners to incorporate hydraulics or pneumatics into mechanical systems or integrate the two, and leave electronics and electrical systems and control out of grade STEM 2 PET, because at the time of doing this PET, learners have not yet done electrical systems and electronic systems as they are done in term 3. So it's advisable for learners just to do mechanical systems integrated with hydraulics or pneumatic systems. Let's get straight into the lesson. Starting off with the definitions. Remember, we're doing pneumatic systems as well as hydraulic systems, and we say a pneumatic system is a system that is operated by air or gas under pressure, and hydraulic system is a system where liquids move in a confined space under pressure. These are the difference between the two. Pneumatics use gases, whereas hydraulics use liquids. And very importantly, we're not saying hydraulics use water, but we're saying liquids, because mostly in most machines they use oil as compared to water. And the hydraulic system do have some advantage over pneumatic systems, because they give us, for the fact that the liquids cannot be compressed, they give us a better force. And the other thing is, where you're using oil in hydraulics, it works as a liquid for applying pressure and as well for lubrication. Whereas in pneumatic system, you're going to use air to apply pressure, but then you'll have got to need to get something else for lubrication. So hydraulics in most cases become much advantageous than pneumatic. Let's now look at the compressibility of particles in pneumatics and hydraulics. We are saying gases in pneumatics are compressible because their particles are loosely packed. And later on, we'll be looking at the compressibility of particles in the 3 phases of matter, that is, your liquid, solid, and gases. Liquids like water or oil in hydraulic systems are incompressible because their particles are closely packed. With respect to gases, liquids particles seem very, very closely packed, whereas when you compare it to solids, it's much looser than. Let's get straight into the arrangement of particles in matter that I've spoken to earlier. We are saying in solids, particles are closely packed. Solids have a defined shape. They also have fixed volume. They can not be compressed. You can try and compress solid as much as you can. You won't be compressed. Then we get to liquids. We're saying liquids are the particles of liquids are closely packed. They take the shape of a container. Liquids does not have got their own definite shape. Take the shape of the container, and liquids have fixed volume. Liquids have fixed volumes. Cannot be compressed, just like solids. When you get to the gas particles are loosely packed, as you can see. It's like it fills itself up in the container. It takes the shape of a container, that's a gas. It has a volume of a container. It fills itself up inside the container. That is why it becomes very easy to compress it, because now of the looseness of these particles filling up in the container. When you compress them, they go to almost the size of a liquid that's in the same size of a container. Now, I want us to do an experiment in order to prove that indeed gases are compressible and liquids are not compressible. We would need 2 cylinders with plungers, the one cylinder filled with air and the other cylinder filled with a liquid. And we compress both. We push plungers of both cylinders and see what would happen. Now, this is the first cylinder. This apparatus are taken from the physicsanimations.com. Now, as you can see, the plunger is moving way down, compressing something inside or something contained in this kind of a cylinder. We don't know what it is yet, but by virtue of just watching the movement of a cylinder, we can already tell that this must be a gas, not liquids. Remember, liquids can never be compressed. Therefore, the plunger cannot move this distance in liquids. This is cylinder A, and as I said, we'll be compressing a gas. Remember that we need here in this experiment to check as to which plunger is going to move for a longer distance as compared to the other, with respect to cylinder A and cylinder B, and one containing liquids, the other containing gases. Still on cylinder A, I just wanted to check, just placed in the double arrowed line there. I want you to look at the movement of our plungers, straight from one end of the line to the other end. Just look how far it moves. Now let's get to the other cylinder containing liquid. It's as if it's not moving. That's cylinder B. And it's obvious that this must be liquids. You see, the distance moved by the plunger. Look at it. It's like it's not moving at all. So it proves that gases can be compressed and liquids cannot be compressed. Let us now conduct yet another experiment. Remember, we're still working on pneumatics and hydraulics, and we want to have a clear distance on how the two work and on the similarities and the differences between the two, advantages and disadvantages of using either of the two. Now, we're going to need 2 syringes here, one filled with air representing pneumatics and the other one filled with water representing hydraulics. Number 1, we're going to describe the difference that you notice between using air and syringe, air in the syringe and water in another syringe. There we go. The first syringe filled with air and the second one filled with water. Remember, the one filled with air is representing pneumatics and the one filled with water is representing hydraulics. What will be the observation as and when you try to push the plunger in air-filled syringe, and what would happen when you push the plunger in water-filled syringe? Very interesting, yeah? What's going to happen? The thing is, you're going to feel more pressure on that finger wherein we are using water than on the syringe where we are using air. We simply tell you that pneumatics exert lesser pressure than hydraulics. I think if you've done that experiment on your own, as we're speaking, you are allowed just to pause the video and experience that yourself. Observation, like I said, less was experience in gases and more on. In this next experiment, we are trying just to check the distance moved by plungers in small syringes and in big syringes, and as well the force exerted in small syringes and in bigger syringes. And later on, you'll understand that this is directly linked to Pascal's principle. But for now, let's check what we want to test. We're just going to use our small syringe as an output, which is a slave, and our bigger syringe as an input, which is the master cylinder, meaning that we are going to be pushing the plunger of a bigger syringe and observe what's going to happen. Number one, what we need to observe is the distance moved by both the plungers. As in when you press the bigger plunger, what will happen to the smaller plunger of a slave syringe, which is the output syringe. Now, we as well have got to describe the amount of force exerted on the big syringe, which is an input or master cylinder. How much force are you going to need in order to push that? If you did the experiment whilst I was showing the apparatus, which is in this regard bigger and smaller syringe combined by that elastic tube in between, you'll agree with me that a plunger of a larger input cylinder is going to move for a very small distance when pressed, and that of a small output cylinder is going to move for a longer distance. And as well, a large force is going to be needed to push the plunger of a larger cylinder, and the force that's going to be exerted on the output, which is on the smaller cylinder, is going to be very less. Now, let's take the very same syringes once again, but this time we are going to use a bigger syringe as an output, which is a slave cylinder, and a small cylinder is going to be used as an input cylinder, which is a master cylinder. And let's check what happens. Remember, we do the very same experiment, but now we've just changed the master and the slave. In this regard, the small cylinder becomes a master. Let's check what happens. When you push it, you're going to need lesser force. Now you remember you're pushing the smaller cylinder, pushing the plunger of a smaller cylinder. You're going to need lesser force, but it moves for a longer distance. And the observation on the output, which is a bigger cylinder, would show you. We can therefore conclude that when a plunger of a small input syringe is pressed, thereby moving a plunger of a large output syringe, it will move a longer distance as compared to the plunger of the output large syringe. Less force is used in the input and large force is experienced in the output syringe, as illustrated in the next picture. Now, as you look into this picture, you realize that it gives us a summary of what you've been talking about in the previous two experiments. Here we've got a smaller cylinder and the bigger cylinder, which is cylinder A and cylinder B. Now, look at the plunger of cylinder B. It moves almost 10 times more or 5 times more the distance moved by the plunger of the bigger cylinder, which is cylinder A. That one moves only for 2 centimeters. This one's going to move for 10. So it's really moving for a longer distance. So it tells you that the smaller the cylinder, the larger the distance moved. But let's now look at the force applied. See, as you look into suppose the smaller cylinder as an input or a master cylinder, just going to need a little force of 10 newtons to move a force which is 10 times bigger than the input, which is 100 newtons. That is why it becomes very easy for you as an individual to be able to move a car up. That is the introduction to pneumatics and hydraulics, ladies and gentlemen. The next topic that we'll be talking about is the Pascal's principles, and we as well are going to be talking about the practical applications of pneumatics as well as practical application of hydraulics. My name is Asaf from SAGET Tech. For more of these videos, keep watching SAGET Tech on YouTube. Thank you.